In this example, superposition still works, but there is one rule that cannot be skipped. We turn off only independent sources. A dependent source stays active in every subcircuit because its value is controlled by the circuit variable we are solving for. Here the target is Vx, the voltage across the 15-ohm resistor, and the dependent voltage source is equal to Vx divided by 3. The original circuit has 3 independent sources: a 75-volt source on the left, a 5-amp current source in the middle, and a 150-volt source on the top branch. We will find Vx as the signed sum of 3 contributions. So Vx equals Vx1 plus Vx2 plus Vx3. For each contribution, the dependent source remains in the circuit, but its value becomes that contribution divided by 3. First, keep only the 75-volt source active. The 5-amp current source becomes an open circuit, and the 150-volt source becomes a short circuit. Now write Kirchhoff's current law at the Vx1 node. The current through 30 ohms is Vx1 minus 75 divided by 30. The current through 10 ohms is Vx1 minus Vx1 divided by 3, all divided by 10. The current through 15 ohms is Vx1 divided by 15. Adding these currents gives 0, and simplifying gives Vx1 equals 15 volts. Second, keep only the 5-amp source active. The 75-volt source and the 150-volt source are both replaced by short circuits. The current source arrow points downward, so in the node equation it is a 5-amp current leaving the node. The 3 branch currents are Vx2 divided by 30, Vx2 divided by 15, and Vx2 minus Vx2 divided by 3, all divided by 10. Together with the 5-amp source, the equation gives Vx2 equals negative 30 volts. The negative sign means this source drives the 15-ohm voltage opposite to the chosen Vx polarity. Third, keep only the 150-volt source active. The 75-volt source becomes a short circuit, and the 5-amp current source becomes an open circuit. Because the 150-volt source sits between 2 non-reference nodes, use a supernode. Let the node to the right of the 150-volt source be VA. The source constraint is Vx3 minus VA equals 150. The supernode current equation is Vx3 over 30 plus Vx3 over 15 plus VA minus Vx3 over 3 divided by 10 equals 0. Solving the 2 equations gives Vx3 equals 90 volts. Now add the 3 signed contributions. Vx is 15 volts plus negative 30 volts plus 90 volts. Therefore, Vx equals 75 volts. The important takeaway is the handling of the dependent source. Independent sources are deactivated one at a time, but the dependent source stays active and follows the contribution variable in each subcircuit.